Alright, today we're doing mixed numbers and what we call improper fractions. Now last time we looked at fractions and we saw that they were describing quantities that were like parts of one whole. But fractions can actually be bigger than one. So take this for example, it's 5 over 3. What we saw last time was that you take one whole block and the 3 on the bottom means you cut this block into 3 bits. The 5 at the top means that you want 5 bits, so you take 1, you take 2, you take 3, and you realize you need more, so you make more. You take 4, and you take 5, and so that's what 5 out of 3 would look like as a fraction, right? Now the way we write this sometimes is you look at what you've got carefully and you see that you've got one whole block there. So you can write this as one whole. And then the fraction part is the part down the bottom where you have this, that's 2/3. So you've got 1 and 2/3. And those are two different ways of writing the same amount which is pictured there. It's either 5/3 or 1 whole and 2/3. The 5 over 3 is what we call an improper fraction, and the 1 and 2/3 is what we call a mixed numeral or a mixed number. Now these names, I really don't like them. Actually in maths, it's almost always easier to deal with the pink one, the improper fraction. Improper seems to suggest to you that something's wrong with a fraction. That's not true at all. I don't know why they're called improper. They actually work like any other fraction would. And actually they're much easier to work with in a lot of maths, right? So I rather think of it as the pink one is like the maths way of talking about these guys, whereas the orange one is more the real life way of talking about these. Like, you would say things like, oh, there were 3.5 pizzas left over last night. You wouldn't say there were 7 over 2 pizzas left over. You just don't talk like that, right? So it's more that the one on the left is what we use in maths. The one on the right is what we use a lot in real life. Okay, I don't want you to think that something's wrong with improper fractions. Actually, quite the opposite. Often, putting things as improper fractions is an easier way to work with them. Okay, and the one on the right is just used to describe things in real life. So that's what we call them, though, unfortunate names, and there's quite a few of them in maths, but we deal with it. The rest of today, we want to be able to switch between the two of them, to convert between the two. So the first direction we'll do is converting the orange one into the pink one, converting a mixed number into the improper fraction. Okay, the first thing you notice is that number on the bottom, that denominator, is really important, because what it tells you is we want to see every whole block as being cut into 5 parts, into 5 bits. Right, so when we mention whole numbers, like 1 and 2 and 3 and 4, right, we want to think of them as being cut into 5 bits like that. That's what one whole is going to look like because of that 5. Right, now look back at the fraction. We've now got 4 of these whole blocks, and so we better take 4 of them, so it looks like this. And let's just pause there for a moment and count up how many bits we have. Each block holds 5 bits. We've got 4 blocks here, and so in total, that should be 4 times 5, which I hope you know is 20, but we won't write that just yet. We're going to hold that, okay? But right now, we've got 4 times 5, which is 20 bits. Right. Now look back up at the fraction. We haven't dealt with the 2 yet. We've sort of talked about the 5, we've done the 4, we haven't dealt with the 2 yet. What the 2 is telling you is that we have 2 extra bits. So we need to imagine a new block, but we're not taking the whole block, we're only taking 2/5, 2 out of 5. So we have to add these 2 bits to the ones we've already got. Now we already had 4 times 5, and we want to add on these extra 2. And so 4 times 5 now we can know is 20. 20 plus 2 is 22 bits. Right, so that's counting up every bit we've shaded there. The blue ones on the left, there's 20 of them. The pink ones on the right, there's 2 of them. In total, there's 22 bits. So what's our answer going to be? Because there's 22 bits, that's the number on top. And how big is each bit? How small is each bit, right? What are we cutting things into? We're cutting things into fifths, into every block's being cut into 5, and so 5 is that number on the bottom. And so that's how you turn an improper fraction, a mixed number, into an improper fraction. Okay. All right. Other way now, converting this fraction into a mixed numeral. Okay. Once again, we want to start by looking at the bottom number. This one is a 6, and what that tells you is that every block is being cut into 6 bits. So you want to think of, again, every block being cut into that number of bits. And when we want 23 of them, well, that's a lot, right? How many entire blocks do we need to take? Because each block only holds 6 bits. I want to get 23 bits in total. So really what I'm asking is how many entire 6s fit into 23? All right, and think about that for a moment. How many 6s go into 23? Well, that's just a division question, isn't it? It's 23 divided by 6, all right? And so hopefully you know your times tables. How many 6s go into 23? Well, the answer's 3 and a little, 3 and some bit that we'll deal with afterwards. But we know that 3 entire 6s will fit into 23, so I can draw that to start with. All right, but there's not enough bits here, right? We want some extra bits as well. And 3 6s are only 18, so I've only got 18 bits in front of me right now. The extra little bit I need is going to be the remainder when we divide 23 by 6. So 6 3s are only 18, not quite 23 yet, but the remainder that we need to get to 23 is 5. And what that tells you is you need 5 extra bits. So 1, 2, 3, 4, 5, off we go there. Right, and so what's our answer now? Well, let's split this up into the entire blocks and the extra little bits, which a mixed number is. How many entire blocks could we get? Well, I think if we look at this one, we can see that we need 3 entire blocks. How many extra little bits did we need? We needed 5 extra little bits. And what was the red number, the number that we're cutting each block into? Well, it was just a 6, and so that's the number on the bottom. Okay, and that's how we turn an improper fraction into a mixed numeral. Thanks for watching, and I'll see you guys next time.